In this session, we will discuss about testing of cement. Among all the tests of the cement, we will discuss initial and final setting time of cement. Then we will discuss soundness of cement. So let us start with the initial setting time and final setting time of cement. This test is divided in two portions. In the first portion, we will find initial setting time and then we will find the final setting time of cement. What is initial setting time? It is defined as the period of elapsing between the time when the water is added to the cement at the time which needle of 1 mm square section fails to pierce at the depth of 5 to 7 mm from the bottom of the mold, because we are using the 1 mm square needle in this test for finding the initial setting time, and in the final setting time we will use 5 mm diameter bottom. So now let us start our test. You can refer Indian Standard 4031 Part 5 1988. And if we talk about the apparatus for finding the initial setting time, we have to use YCAT apparatus. And YCAT apparatus, you can see on your screen, this is the YCAT apparatus and it's containing the screw, indicator, and this is the mold which is placed on non-porous plate, and this is the movable rod, and we have to allow this rod with its own weight, and this is the needle. In the initial setting time we will use 1 mm square needle, and in the final setting time we will use 5 mm diameter bottom. And other apparatus we require balance for preparing the cement paste, and next is beaker and gauging trowel, and we require stopwatch for the measuring of the time. Now let us start the procedure for finding the initial setting time. First of all, you have to prepare the cement paste with the 400 gram of this cement, and you have to add the water content. But before the adding the water content, you have to calculate the quantity of the water mass. As we know, first of all we have to find out the consistency of the cement mass. After that we can find out the initial and the final setting time and other tests like the soundness of the test and the compressive strength of the test. So first of all we have to find out the consistency of the cement mass, then we can calculate the quantity of the water mass. So we have to calculate the mass of the water with the consistency of the cement mass. You can see on your screen, for example, your consistency is 26% and your cement mass is 400 gram. It means you can easily calculate the 0.85, which is the equation for the initial setting time, and multiply by 26, which is the consistency of the cement, divided by 100 multiplied by 400 gram, which is the mass of the cement. So now you are getting the 88.4. It shows the mass of the water. This quantity is you have to add in your cement paste, and you have to use the 1 mm square cross sectional area and 50 mm long for finding the initial setting time of the cement mass. First of all, you have to prepare your cement paste with the calculation of the water mass, and after the preparing the paste you have to fill this paste in this mold. You can see on the screen the paste should be placed in the mold, and then you have to attach this 1 mm square needles in this apparatus, and then the movable rod is pulled the upward direction, and then you have to allow it with its own weight. As we know, in the starting time, the high liquidity contain the cement paste. With the increasing the time, so there will be losing the liquidity and there will be increase the plasticity of the cement mass due to the removal of the moisture content. So in that case, in the starting time, you are allowing the attachment. So there may be zero reading appear on your apparatus, and after this some time you are allowing the needle with its own weight, you may get the 2 mm or 3 mm, but we have to reach the 5 mm to 7 mm reading. This is the main criteria of this test. If you are not achieving this reading, you have to do the other trials. If you are getting the more value of the reading like 15 mm or 12 mm or 20 mm, in that case plasticity contains high. In that case you have to add the water mass to achieve criteria of the reading, which is 5 to 7 mm. If you are achieving the 5 to 7 mm from the bottom of the mold, it means you can easily find out the initial setting time. The time should be measured. The starting time will be start from the water mass is added to the cement. This will your starting time. And when your reading will reach the 5 to 7 mm, it means this is your stopping time. So you have to measure the difference between the starting and stopping. It means you can easily find out initial setting time of the cement. And in the other case, you can also calculate the 33 to 35 mm reading from the top of the readings. Here you can see on your screen 0 mm, 0 to 5 mm, 0 to 10. Just we have to reach the 5 to 7 mm from the reading. So you have to reach this reading between 5 to 7 mm. This photo shows that your zero reading. It means in the starting period you may getting the zero value of the reading, and after the certain times you will achieve to 5 mm to 7 mm value of readings. So this is your stopping time. So you have to calculate the water mass when you add it to the cement paste to achieving the result value of 5 to 7 mm from the bottom. So this will be your initial setting time of cement. Now let us discuss the final setting time of cement. What is the final setting time of cement? The period elapsed between the time when the water is added the cement at the time at which the needle makes an impression on the surface of the test block. The attach fails to do so shall be the final setting time. So first of all, in the final setting time, you have to replace your needle with the 5 mm bottom, and you can see on your screen this needle is used for the initial setting time, which is the 1 mm square and 50 mm long, and this needle is used for the final setting time, which is the 5 mm bottom diameter. If we talk in the simple language, just you have to allow this needle with the 5 mm diameter bottom. When you fails the makes the impression on your mold, so you are getting final setting time of the cement. First of all, you have to prepare the paste mass as we have discussed in the earlier, and then you have to start your stopwatch when you add the water mass in the cement paste, and you have to start your impression on your mold with the 5 mm mold. In the initial period, you will appear the impression due to the high liquidity of the paste, and after the setting of the cement paste you will fail at the certain time to fail the impression of the cement paste. It means that is your final setting time. First of all, you have to start your stopwatch when your water mass is added to the cement paste, and then you have to stop your measuring time when you fail the impression of the paste. So this will be your the final setting time of the cement mass. So with these procedures, you can easily find out initial and the final setting time of the cement. Now, observation and result. Here the table shows that the time when the water is added in the initial setting time and the final setting time, both both timing will be measured from the water is added to the cement mass. In the both test, you have to start your stopwatch when you add the water mass in your cement paste, and in the initial setting time you have to stop your stopwatch when your 1 mm square needle is reached to 5 to 7 mm from the bottom of the mold, and in the final setting time stopping time will be when you files the impression of the mold with the 5 mm diameter of the bottom. So generally the initial setting time should be more than 30 minutes because your manufacturing of the cement mass to the placing of the cement mass, it requires minimum 30 minutes. If we talk about the final setting time of the cement mass, it should not be more than 10 hours. So this all about the initial and the final setting time of the cement mass. This initial and the final setting time we can modify as per our requirement with adding the admixtures. But in the general concreting, we are not disturbing this initial and the final setting time of the cement. Now, let us start the soundness of cement. In the cement mass, we are facing some issues like the expansion. So we have to find out the soundness of the object of this test is to cover the procedure for the determining the soundness of cement, and you can refer the Indian Standard 4031 Part 3 1988, and you can also refer Indian Standard 5514 1969, and apparatus used for finding the soundness of cement. We will use Le Chatelier apparatus balance for the making the paste of the cement mass, and water bath and the beakers will be required for finding the soundness of cement. Now let us understand the procedure of finding the soundness of cement. First of all, you have to prepare the cement paste, and for the making this paste you require 100 grams of the cement and certain quantity of the water mass. Before the adding the water mass, you have to find out the consistency of the cement mass. With the value of the consistency, you can identify the required quantity for this test, and 78% of the consistency for the soundness of the cement mass. And after the adding this value of the water, and you have to prepare the cement paste, and then you have to place the cement paste in this Le Chatelier apparatus. You can see on your screen, this is the old arrangement of the Le Chatelier apparatus. This is the elevation view and this is the plant view for this Le Chatelier apparatus, and this apparatus contains the glass plates and height is 30 mm and 30 mm diameter is used for the dimension of the paste mass. And with these indicators, we can easily find out the expansion of the cement mass. First of all, after the placing, all the assemble in this of the paste in this apparatus, less Chatelier apparatus, and then whole assembly is immersed in the water at the normal temperature, which is the 27 degree Celsius to 32 degree Celsius, and keep it for the 24 hours. And next, the remove the assembly and immerse in water to measure the distance between the indicators. Here you can see on your screen this is the indicator. First of all, you have to measure this indicator. For example, we are designated by the AA. After this procedure, we have to submerge all the assembly into the water again and heat the water and bring to the boiling point about 25 to 30 minutes and keep it boiling for the 3 hours. Now we are introducing the heat, and then we will find out expansion of the cement mass. And now the measure the distance separating the indicators. Now after this procedure, you have to once again the measure this distance, and this distance will be increased by these procedures. So you have to find out the difference between the second reading and first reading. So you can also calculate the expansion of the cement mass. That will be your soundness of the cement. And for the good quality of the cement, the expansion should not be more than 10 mm. For example, your first reading is 18 mm and second reading is 14 mm. It means your difference is 4 mm. It means this is the acceptable value. And if this value is increased greater than 10 mm, it means your cement mass is failed regarding to the expansion of the Indian standard criteria. So your cement expansion should not be greater than 10 mm. Here you can see the observation. First of all, you have to note that the time when water is added, and here you can see the observation table on your screen, the initial distance and the final distance and expansion. For example, our first reading is initial reading is 20 mm and final reading is 15 mm. It means our expansion value is 5 mm. It means this is the acceptable value. So this is all about the soundness of the cement. This soundness value should not be greater than 10 mm. Thank you.